Hello, this is Sharon Sarago. Today we're going to talk about area and perimeter. You've already been exposed to this many times, many years. These are not going to be new to you, so we can take a very quick review. First of all, with rectangles, you know it's a quadrilateral with 4 right sides, and I suspect you already have this formula committed to memory. The perimeter is all the way around, just like that. So you can say 2 lengths plus 2 widths, just start adding them all up. The area is the length times the width. If we have a rectangle and the perimeter P is 2 times 8, because I have this one, and 2 times 5 here and here, that equals 26. And the area, of course, is length times width, which would be 8 times 5, which would be 40. Let's look at squares. A square is a rectangle with 4 sides of equal length. Again, you need to have the following formulas memorized. For the perimeter, it's just 4 times side, since all the sides are equal, or just add up all the sides. For the area, it's side times side, because basically we're doing length times width. And if they're all equal, it would be this side times that side, or side squared. Let's look at an example. A rectangular area measuring 16 inches by 4 inches is to be tiled with 2-inch squares. How many tiles will be needed to cover the area? Well, first of all, you know that we know what the area of the whole thing is going to be, because we can multiply 16 by 4. And if we do that, then we get 24. And it's going, 64. And it's going to be tiled with 2-inch squares. So that would be 4 square inches. And then we just find out how many of those are going to be in that 64 inches. Let's look. Total area is 16 times 4, 64 square inches. Each tile 2 inches, that would be 4 inches. So divide 64 by 4, you get 16 tiles. For triangles, there are several formulas to learn, depending on the type of triangle. Basically, if we're looking at perimeter, we want to add all the sides together. A plus B plus C. If we're looking at area, the formula is 1/2 base times height. Just remember that this is your base, and this is your height, coming straight down from the vertex here. This is not the height. That's just another side of the triangle. The height is also called the altitude, and again, note that it is not the side of the triangle. This is the height. It's the perpendicular distance from the base to the opposite angle. For a right triangle, the base and the altitude will be the legs of the triangle. So the formula for area becomes 1/2 leg times leg, or 1/2 base times height. This is still the base, this is still the height. In an equilateral triangle, the sides are all the same length, and so the formula for perimeter becomes side plus side plus side, or you could multiply it and just say 3s. Then there is a specialized formula for the area of an equilateral triangle, which comes directly from the general formula area equals base times height. Recall that in an equilateral triangle, all of the angles measure 60 degrees, and the height of the triangle will be 1/2 side times the square root of 3. If we insert this into our general formula, the formula becomes this. Area is 1/2 base times height. It's 1/2 of the side times the height, which was 1/2 of the side times square root of 3. And when you combine those terms, you get side squared over 4 times the square root of 3. So you may be kind of wondering how in the world we got such a thing like that. Let me see if I can help you. I'm trying to get my pen to work here, and it doesn't seem to want to. Well, when you look over here, you have a right triangle. right? And it's a 30, 60, 90 degree triangle. Remember that our formula for that is side to side, side root 3. And here's where that side root 3 comes from. But if I'm trying to say 1/2 of the base, that would be 1/2 of this side times the height. And this was my height, side root 3. Then my area formula is 1/2 times the side here times this height, side root 3. You combine those, you get side squared over 4 times the square root of 3. Here's an example. What is the area of an equilateral triangle with a perimeter of 30? So if we have a triangle and we know that the perimeter is 30, then what is each side? We have our triangle here. The perimeter is 30, so each side would have to be 10, wouldn't it? And we're trying to look for the area of that triangle. The area is 1/2 base times height. This is an equilateral triangle, so it would be side squared over 4 times the square root of 3. And that would be 10 squared over 4 times the square root of 3. So let's just take a look at this. If we have an equilateral triangle right here, and we know that the perimeter is 30, that means that each side would be 10. If we plug in this formula right here, our side squared would be 10 squared over 4 times the square root of 3. 10 squared is 100 over 4 times the square root of 3. And that would give us 25 times the square root of 3. You understand? And I believe that's going to be one of our answers. There it is, D. Alright, and then here's an explanation for it again. Alright, now we're going to talk about the area and parameter of a parallelogram. Remember that a parallelogram is a quadrilateral with two pairs of opposite sides parallel. So we have A and A are two sides. They're parallel, as are B and B, both parallel. But remember, this is not the height of your triangle. This is your altitude, your height. Remember that the perimeter is just all the sides added together, or 2 A's plus 2 B's. And the area is base times height. I want you to remember that what you're dealing with here is basically just a regular rectangle, except it fell over, right? So if this area is equal to the length times the width, or the base times the height, you still have the length times the width, and we still have the length times, it's not going to be the width, what's the length? Another word for this is the base times the height. That's what we need to think about. And now it becomes the base times the height, not the width. All right, it probably would be better for you to say the base times the height always and forget about the length times the width, because when you look at a parallelogram, then you would still know it's the base times the height. It's not the length times this width, which you're going to say is the width of it. Here's an example. What is the area of the parallelogram shown at the right? And remember, our formula is base times height. So, of course, it would be 6 times 4. Another problem. If the area of a rectangle is 24 AB and the length is 6 AB, what is the width of the rectangle? So, my whole area was 24 AB. and they told me that the length of it was 6b. In order for me to wind up with an A, you know that my width here is going to have an A in it. So if this is 6, and remember that this is the length times the width, 6 times the width is equal to 24, so I know that my width then must be 4. Okay? Let's see here. Then we'll go on to the next problem. Let's see if that's our answer. Okay. 4a. A square is inscribed in a triangle as shown. If the area of ABC is 54 and the area of the unshaded is 18, so the area of the whole triangle is 54 and the area of the unshaded, that's just this white, is 18. If I subtract those, what I'm going to be left with is the area of that colored part. And so, what do I get here? 36. So that means that the area of this part is 36 square units. So what would the side be? What times what is 36? Of course, that would be 6. And that was what the question was what was one side of it. Another one. A triangle is graphed on a standard coordinate plane. And people, when you do this, you have to draw it. And it says it has its vertices as a negative 5 and a 0. And the minute you put your little dot down, put down your coordinates always. And another one at 0 and 4. 0 and 4. There we go. Put down the coordinates. And another one at 1 and 0. Now, it's a triangle, so we're going to connect it here. And I want to know what the area is. Remember that the area formula is 1/2 base times height. And our base here, from here to this point, was 5. The fact that it's negative has nothing to do with it. It was 5 units from this side to here. We're talking about the length of it, that's all. And one more unit here. So 5 plus 1 would be 6. So we've got 1/2 times 6, and our height was, right here, 4. So 1/2 times 24 would be what? 12. Here's another one. Rectangle ABEF has an area of 72 square units. AB is 12. AF and ED are equal, and so that means that we have to mark that immediately. AF and ED are equal, and BC is 4. Alright, so if we have an area of 72 inches and we know 12 of it, then we should know that this whole side here is 6. 6 times 12 is 72. Let's fill in the rest of the stuff we know. If this was 4, in order for this whole side to equal 6, like this side, then that would have to be a 2. Remember that they said that this and this were equal. That means that ED has to be 6. And they're asking for the area of this small triangle. Well, our formula was area equals 1/2 base times height. So that's going to be 1/2 times 6 times 2, which is 1/2 times 12, and that would make our area 6 of that little triangle. There we go, answer B. Next one, what is the area of the triangle shown in square units? Alright, always we want to draw if we see something that looks kind of interesting. So I see something that's interesting because I know my triples. And we studied triangles, you should know yours too. So when you look at 5 and 13, what's the next number that comes to your head? It's one of your triples. It should be 12. You do not want to have to sit there and try to figure this out with the Pythagorean theorem. You just simply don't. These numbers should be in your head, 5, 12, 13. And so they want the area of that triangle. Remember the formula is 1/2 base times height. That would be 1/2, my base right here is 10, right? 1/2 times 10 times, and my height is 12. So that's 1/2, 120, is that correct? And that would be my area. What are they asking for me? The area would be 60, right here. Let's look at another one. What is the area of the shaded region of the rectangle expressed in simplest terms? Oh, well, this is going to take some algebra, isn't it? All right, we can do that. Just start. You want to know the area of the shaded region. So clearly, we have to know this big area minus this area. All right, so area 1 is going to be our big one. It still equals the length times the width in this rectangle. So we've got 5x times x plus 2, right? Do a little multiplying here. We should have 5x squared plus 10x. Okay, and that's our area. Area 2 is still length times the width, and on this one we have 2x times 3x plus 1. And that would be equal to 6x squared plus 2x. Our original premise was we needed to know this large one, which was 5x squared plus 10x, and subtract this small one, which was 6x squared plus 2x, and we'll get the area of the shaded region, just that minus this. So we're going to subtract that. Remember to change signs. We're going to get a negative x squared plus 8x. That's what it looks like. Let's see if that's one of our answer choices. There we go. Negative x squared plus 8x. Okay, these are the answers for those questions. Now, in your printed materials, you have a whole lot of these to do. I want you to start with number 1 and work all the way through them. If there are any of them that give you trouble, that you don't understand, or that you maybe got but you guessed, mark that so that when we meet together on either Saturday or Monday, then you can talk to me and say, well, I didn't really understand how this one works. So until then, I will see you later. Good luck on all of this.